All right, let me see if I can try this. What's up, YouTube? It's your boy Joe back with another hopefully shorter tutorial on how to squeeze a little bit more detail out of your brand new shiny GoPro Hero 11. Hey there, Future Joe here. Forgot to mention that most of this process is going to require the studio version of DaVinci Resolve, aka the paid version, and it's probably going to require a reasonably beefy PC. If you got a good gaming machine, this is going to work fine. But if you're trying to do this on a $130 Walmart machine, don't even bother. It's not going to be possible. Okay, back to our scheduled programming. This video is sponsored by your mom or some shit. I don't know. Let's begin. So, GoPro Hero 11 has a slightly larger sensor and a lot more resolution than the Hero 10. We can see that if we take a look at these files that I have loaded here in Resolve. The Hero 11 source file shot in 8x7, which is the full sensor. 5312 by 4648. We compare that to the Hero 10 Super View, which is 16:9, that's 5312 by 2988, or the 4:3 source, which is 5120 by 3840, which is a decent resolution. The key thing here is how we address it in GyroFlow. GyroFlow by default wants to take our 8x7 and export it out as 5312 by 2988, but you can tell we've got, relative to the Hero 10, we have 808 additional vertical lines of resolution, and we've got 192 additional horizontal lines of resolution. So why don't we try to hold on to that resolution? And when we export out of GyroFlow, we're going to get a much higher resolution file, but we're going to be able to capture more of the stretched pixels when it does perspective correction. So if you recall, when we stretch those pixels out, the original pixels, which start square, they change shape. They're rendered out in this stretched out diamond shaped, and then the blue here represents what we're attempting to capture from that render. So as it gets stretched out, we're actually losing pixels off the edges here, and this kind of moves it around a little bit, so you may end up losing even more pixels off the edges because as it's stabilizing, it's moving this big diamond stretched out image around and making sure that the edges don't come in and touch the edges of the blue square there. So the blue square would represent what we're rendering out, and the red distorted square would represent the distorted footage. Well, I mean, it's undistorted as far as its appearance goes. It's perspective correction and undoing the lens distortion, which requires stretching out the corners quite a bit. So what we'll do here is we're going to flip over to GyroFlow and make sure I've got this open. So I'm going to take my denoise footage. If you recall in the last tutorial, I showed you guys how to go through, well, I didn't show, I actually explained. But basically you're going to take your original footage at its original resolution into Resolve, run the denoiser, and then export that at its native resolution, but 444 10-bit as opposed to 420 8-bit. In this case, for the Hero 11, I shot in 10-bit, so it's going to be 10-bit, but it's still 420. Kind of going back to that concept here. Basically, chroma subsampling is it takes a group of 4 pixels, and while each pixel has its own individual luminance value, how bright it is, in 420, groups of 4 pixels will share how or what color is represented in that group of 4 pixels. So you do get some color detail because the luminance value of the color will change, but it is all the same color. What we're going to do here is we're going to take advantage of the additional resolution that we're getting out of the Hero 11, and we're going to bring it down to an actual real 444 subsampling, basically no subsampling, where each pixel will have its own individual color and its own individual luminance value, which increases the color detail by a factor of 4, honestly. So that's what we're going to try to accomplish with this little hack. So let's get right into it. Get that out of the way. So I am going to drag over my denoised file. So denoised right here. And you can see up here, it's 444 10-bit. This is the file that I exported out of Resolve. Need to load a lens profile. Okay, and then I need to load the original file to grab its gyro data. Done and done. And then for giggles, we're just going to hit the auto sync to make sure that the gyro data syncs up perfectly in case there was a missed frame in the original file that we exported. We just want to make sure that it's all there and there's not going to be any kind of weird jitters or craziness. We'll speed this up real quick. Okay, we got our sync points in. You can see it's got a little bit of a variable length. Give it a quick play just to see what it looks like. Pull it up here to where we can see some action. So this is my default stabilization, which is 100 millisecond smoothing window and no secondary smoothing pass. Just the default stabilization style. So just to illustrate what I was showing before, if I bring this field of view up, you can see how stretched out the corners are. And all of that is data that we would be losing. But those pixels become diamond shaped as they get stretched out. So we want to minimize the amount of data that we lose because we, in the center here, we still have that amazing vertical resolution. We want to take advantage of that as best as we can. We're going to maintain that vertical resolution and double pixels for the horizontal resolution. But then when we go back to 4K, everything's going to shrink down and fit into the 4K pixel nicely. So I will set this back to 1.0. Boop. Alrighty. So this looks fine. I mean, it's a little choppy, but it's a huge file. Again, we're going to export 600 megabit and my custom encoder options there to make sure we get 444 10-bit out of NVENC. But what we're going to do here is we want to scale this resolution up to be as close to the vertical resolution of the original file. So 2988, it's a lot of pixels, but we want a little bit more. Now, if we change this to 4648, that vertical resolution in the original file, this will go above 8192, which is the limit of, it's the upper limit of the encoder's ability to encode a file. So we don't get to quite scale perfectly up, but what we're going to set this at is 8192 by 4806. Oh, wait, other way around, 4608. There we go. So that is going to give us the absolute most resolution possible, 444, 10-bit color, and we will just hit, yeah, we'll go ahead and change this real quick. All right, and we'll hit export, and I'll speed this up so we can skip through it. And we are back. So just for reference, that took about 22 minutes. It's up to you to decide whether or not that time is going to be worth it for you to get this extra detail. I have a fairly beefy machine with fairly beefy GPUs and gobs RAM, so your mileage may vary on exporting 8K video from GyroFlow. So we'll go ahead and head over back to Resolve. We're going to take our freshly rendered file. Just as a reminder, I think put it in the beginning. In order to export your denoised at the same resolution that it came out of the camera, you're going to need the studio version. I mean, you're going to need the studio version for a lot of this anyway, because it requires GPU compute in order for it to be at all reasonable. And the free version does not use the GPU for compute. It can use it for encode, but only up to 4K. So you won't be able to get this file out of Resolve. So now that we have our 8192 by 4608 file, now we can actually begin looking at working with this file. Array. Okay, so we'll take it to right there, give or take, beginning. And I don't want to see my fat ass in there, so we'll back that up. Good enough. I'll drag it down to my timeline. I'll leave the audio out this time. All right, and we'll head over here. We will first, I'm just going to go ahead and throw on a color or a color correction, and then do my typical 3-node color grade. And there we go. That's not looking too bad. So if we go full screen with this, remember, we're working with an 8K source file. This may or may not play smoothly on your machine. I guess I'm lucky enough that it's playing fine on mine. So if I go full screen, you kind of get an idea for this sort of detail that we're working with here. So we're going to get the most resolution towards the center vertical of the image, and it's going to lose resolution as objects head towards the edges, because if you recall, those pixels are being stretched, right? So what we're doing here is we're sampling these stretched out pixels with a lot more pixels so that we can capture all of the edges and anti-alias them by throwing a lot of pixels at them. So what we end up with is a lot of natural detail, natural sharpness without having to use anything artificial in order to get that detail, even in 24 frames per second with 180 degree shutter speed, and you get that natural motion blur. You can still easily see the detail in what we're getting here, and it seems to be, you know, leaps and bounds above what you could get with the Hero 10. It is a bit, I guess, extra is what the kids are saying these days. Only the most anal of people are going to notice the additional detail. But if you want to maximize the amount of detail you can get out of the Hero 11, this is how you do it. Hey there, Dumbass Joe here. I forgot to mention in this tutorial to make sure you export this file as main10 444 from Resolve. Again, another reason why you probably need the studio version. I don't know if that option is available in the free version, but that way, final file, every pixel is going to have its own individual color with its own individual luminance value, and that way you're going to give YouTube the highest quality video possible instead of allowing YouTube to just filter an 8K file. You want to give them the 4K file, so it's 4K 24 frames per second, exporting out main 10 444 and H.265. I mean, if you want to do something like DNxHR, you know, 12-bit 444 or ProRes 444 or whatever you want to do, that's fine. But if you're going to upload to YouTube, H.265 works pretty well as long as you give it to them, and crank up the bit rate to like 600 or 900 megabit per second. And your mileage may vary. So yes, I might recommend if you want to know how I did that correction and how I did the quick color grade, headed back over to my super long tutorial on color correction for GoPro cameras. That one's a bit more inclusive for most action cameras. In this case, this one is just for the Hero 11, although I guess if you wanted to try it with the Hero 10 4x3, you could do that as well, maintaining that vertical resolution and stretching out the horizontal if it's not already at the, well, it's not, because you can see it's 2988 on the horizontal or on the vertical when you stretch it out to excuse me, to stabilized. So yes, thank you for watching, thank you for attending my TED Talk, and we'll see you on the flip. Goodbye.